Print out your practice tests. There's one worksheet on our Canvas page, extra practice of graphing. Use those wisely. You ready? You guys have been waiting for this. Well, those of you who have seen this before. All right, we are going back to limit world. Let's remember limits, right?
Yeah.
I love having this section in test 3 because it's great benefit for the final. You have to review your limit rules here, middle of the course, and then you'll have it fresher when we get to the final exam review. So it's kind of a good thing. Now, not all of the limit rules that we covered back in test 1 will be involved here. However, there will be quite a few that we do have to use. So, L'Hopital does not fix all of the issues that you didn't like back in the limit problems. It does fix a lot of them though. So not all limit things will come up again, but as we go through here, we will see some limit techniques that we have covered before. All right, so here, let's review. You have a limit question. What should you do? All right, let's plug in 0. What happens if we plug in 0 here? So we get 3 times 0 minus sine of 0 all over 0. What's sine of 0? 0. So this is 0 minus 0 over 0. You guys remember seeing this before? Is this an answer? No, this means you have work to do. Back in olden days, 7 weeks ago-ish, we would have to use all of those algebra manipulation techniques to be able to find this answer. In this case, it would have been separating the fraction. So 3x over x minus sine of x over x. Separate the fraction, and then the first one you can evaluate, and the second one is sine of theta over theta rule. We don't have to do that anymore though, because today we're going to learn a new technique. This new technique is called L'Hopital. L'Hopital is going to be specifically applied when you have this case right here. 0 over 0, I like to say you're L'Hopital ready. So do you still have to plug in and test and see if you get a limit? Absolutely. By plugging in your x, whatever it's going to, you find out if you have 0 over 0. 0 over 0 is what we're happy about. It means we can use L'Hopital. This is what we call an indeterminate form. Okay, we briefly mentioned that way back week 2 or 3 of class. But here we're going to see a lot of indeterminate forms. Some we've seen before and some we haven't. This list here is actually all the indeterminate forms that we are going to be considering, and then 0, 0 as well. So we've seen infinity over infinity before. That one we've dealt with, especially when we're looking for horizontal asymptotes. The rest of these you might have seen somewhere, you might not, depends on what problems you solve, but we haven't really talked about them. All of these are indeterminate forms. The bad news is we've lied to you your entire math career. 0 times a number. Not anymore. Okay, we didn't lie to you. Okay, 0 times a number is 0. You have to keep in mind that these forms are not actually 0 or infinity. These are the results of limits. It's going to infinity and it's going to 0. They're not actually those exact numbers. You're taking a limit, something approaches infinity, something else approaches 0. The question is, which one goes to its number faster? Whichever one goes faster is going to win the battle. Do they go equally fast and then they just kind of cancel each other out? To figure out these kinds of things, we are going to use L'Hopital. However, L'Hopital does not apply to any of the rules here. For now, it applies only to 0 over 0, and we're going to find ways to use it for the other indeterminate forms. We've also talked about this one. 0 to a power is
1.
0 to a power. 0 squared. 0, right? But what is 0 to the 0 power? Oh, well, that is something we cannot evaluate. Because remember, 0 to a number power is 0. But what's a number to the 0 power? 1. Depending on which one of these zeros you focus on, you get 2 different answers. To know which one wins the battle, so to speak, you have to use algebra, L'Hopital, all those different wonderful things. 1 times 1 times 1 times 1 times 1 is not a number. It's not actually the number 1. It's something that's going to 1 with a power that is going to infinity. Because they're not actually 1 and actually infinity, you have to evaluate this using techniques. All right, so here is L'Hopital's rule. By the way, all the other limit rules you can apply, you can use. L'Hopital is just faster and better in many cases. But if algebra can be used like we did in test 1, then you can use algebra to solve limits. All right, so here's L'Hopital. L'Hopital says, suppose your two functions are 0 if you plug in A. So in other words, this guy here is 0 over 0 if we try to evaluate. Then you can use L'Hopital. L'Hopital says these two are equal to each other. The limit of f over g is equal to the limit of the derivative of f divided by the derivative of g. Notice this is not a quotient rule. We did not take a derivative of the fraction. We took the derivative of the top. We took the derivative of the bottom. That's it. That's the L'Hopital rule. And it says these two limits are the same. So if you can evaluate the new one, great. It's when you take the derivative usually. For example, x squared. Take its derivative. What happens to it? What happens to its power? It went down. If you take the derivative again, what happens to its power? So in most cases that we see, when we take the derivative of the top or the bottom, it's going to simplify, get smaller, and eventually be something we can evaluate. So let's look at some examples here. This one is the one that was at the top of the page. We already plugged in 0, 0. Sorry, we already plugged in 0, and we got 0 over 0. That means that this guy is L'Hopital ready. This is how I'm going to write it. We use L with a circle, or some people use H with a circle. By the way, his name is L'Hopital, not El Hospital or El Hospital, not L'Hopital. He's cool. Anyway, you use L with a circle or H with a circle. If you go on YouTube, you'll see either one. For videos, if you go to tutors, they could use either one. This is how I denote L'Hopital. What I like to do is I like to write the equal sign and I put an L with a circle over it to help whoever's creating my part understand that, hey, I'm going to put L'Hopital right there. When you have L'Hopital, you still have your limit notation. And according to L'Hopital, you take the derivative of the top and the bottom each separately. So what is the derivative of the top? Good. And on the bottom? 1. Do you see how everything's simplified? It got smaller except the trig function? Trig functions don't simplify when you take their derivatives, but everything else simplified. Now, once you do the derivative of the top and the bottom, you apply L'Hopital, you find the limit. How do I find the limit? Plug in your x. So 3 minus cosine of 0. What is cosine of 0? 1. And we get 2. If you find an answer, you're done. All right, on the test, you have a limit question. What should you try first? Plug in what x is going to. So in this case, 0. So square root of 1 plus 0 minus 1 over 0. So that's the square root of 1, which is 1, minus 1 over 0. Oh no. Is 0 over 0 an answer? No, but today we're going to learn that this is a wonderful situation. This means we are L'Hopital ready. We are ready to apply L'Hopital rule. So let's do it. To denote I'm doing L'Hopital, write your equal sign with an L on top. Your limit notation is still there. What does L'Hopital rule say we have to do here? Yep, derivative of the top and the derivative of the bottom. Let's do the easy one first. Which one's easy? The bottom. What's the derivative of the bottom? 1. Yeah, I feel better. Okay. Partial credit. The top is a little bit trickier. Why? What do we need to do first? Instead of square root, we're going to rewrite it. 1 plus x to the 1/2 minus 1. That's the numerator. That's what you're going to take the derivative of. How? Technically, it's chain rule. Power comes down, inside stays the same. What's my new power?
-1/2.
I heard it, -1/2. And then the derivative of the -1? It's gone. Went to 0. It's a constant by itself. Did our problem simplify? Can you see how it simplified? Top and bottom both simplified. Okay, this is the benefit of L'Hopital. What should we try now that we've applied L'Hopital? Plug in what x is going to. So we have 1/2. 1 plus 0 to the -1/2. The 1 on the bottom is not doing anything, so he's gone. So that's 1 to a power. What's 1 to a power? This is 1. Or we can think of it as the square root of 1, and then put it in the denominator. It's still just 1. And we end up with 1/2. Once you have your answer, you're done. Questions? You good? All right. Do you think I'm so bad? I mean, you have to know how to take a derivative. I will give you that. This isn't that bad. Oh, wait. All right, what should you do first? Plug it in. All right, if we plug in 0, the square root would be just square root of 1 or 1. -1 minus 0 divided by 2 is 0 over 0. So 0 over 0. Oh no, that's not an answer. However, if you have 0 over 0, you are
L'Hopital.
L'Hopital ready. You can just apply the L'Hopital rule. What does L'Hopital say we need to do? The derivative of the top and the bottom separate. Don't stress. Work the easy one first. Which one's easier? The bottom, what is it? 2x. The one on top, that first term, does that look familiar? He's what we did in the last problem, right? So we rewrite him as a 1/2 power. So 1/2 comes down, 1 plus x to the new power. Same thing as the last problem. The -1 goes to 0, he's gone, and then we have -x over 2. -x over 2, how do I take that derivative? Think of it like this, he's -1/2 x. What is his derivative? -1/2, good. Questions?
Oh, yeah.
What do we do now? Plug in, if we plug in 0, we get 1/2 times, well, 1 to a power, minus 1/2 over 0. So that's 1/2 minus 1/2 over 0. Wait a second. Did I break it?
That should have gone together.
No, it didn't break. What does 0 over 0 mean?
Gotta do it again.
You're L'Hopital ready. Yes, you can do L'Hopital more than once. However, before you move on, I want you to look at your 2 limits you've had so far. Is L'Hopital making them better? Did it get simpler?
Yes.
The denominator's power shrunk. That's encouraging. On top, we actually lost a term, and then another term lost its power. Yes, the first term's nasty. It's okay. Majority is getting simpler, so doing L'Hopitals is helping. Let's try and do it again. So we're going to take that same one. I forgot to write my L'Hopital symbol. Take the limit as x goes to 0. All right, let's do the bottom first. It's easier. Let's do the bottom. 2. We have this nasty parenthesis here, but he's already a parenthesis with a power written nicely. So what rule do we use? Power. Power comes down and multiplies. So -1/4. 1 plus x to the -3/2. And then what happens to this -1/2 out here? He's gone. He goes to 0. Good. All right. You did L'Hopital. You did the derivative of the top. You did the derivative of the bottom. Now
Put it in.
plug it in. All right, so I have negative 1/4 times, well, that would just be 1 to the negative 3/2 over 2. 1 to a power.
1.
It's just 1. You can work it out if you want to, but it is just 1. So negative 1/4 over 2. Ooh, that's not a good way to leave an answer. How do you clean that up? Multiply by reciprocal. Put the 2 over 1. This is division of two fractions. So the top one stays times the reciprocal of the bottom. We got an answer! Which means we are done. Isn't L'Hopital awesome? I had no idea this problem. Can you imagine trying to do algebra here? It might be a conjugate. That would be a fun conjugate to do, wouldn't it? It's not. Okay. L'Hopital takes away a lot of those funky things that you had to do in the past. Are we good? All right, try another one. It's a limit. What do you do first on a limit?
Plug it.
Plug it in. So if we plug in 0, we get 0 minus sine of 0 over 0. What was sine of 0? 0. So this is 0 over 0. Do we get upset with that? No, we're happy. What does 0 over 0 mean you should do?
Oh.
We're ready for L'Hopital. So we're going to do it. Limit notation, don't lose it. X goes to 0. All right. What does L'Hopital say you do? Good. What's the derivative of the top?
1 by 1 portion.
Well, minus cosine of x is correct. On the bottom, what's the derivative? Do you see how your function has in fact simplified? The powers have decreased except the trig function. All right, what do we do?
Plug it in.
Plug in 0. Now, I'm not going to write it big anymore. I'm going to start showing you. Just do it on the side. If I plug in 0, what's cosine of 0?
1.
1 minus 1 is... Uh-oh. And on the bottom, what do I get?
0.
Is that a problem?
Yes. No.
No, it's not a problem. It means you can
Okay.
do L'Hopital again. Now, I will tell you, if you could simplify your fraction, I would try to simplify, but this one you cannot. So let's do L'Hopital. How many times do you think you could do L'Hopital in one problem? As many as you want is technically the right answer. However, if you're not seeing things getting simpler, stop. Okay, L'Hopital can make things more complicated, which means it's not helping you. Let's see a case in a little bit. All right, so derivative of the top. What happens to the one? It's gone. Negative cosine, his derivative would be
Sine.
positive sine. Good. And on the bottom? All right, are we making progress? Did it get simpler? Again, it did. We lost a term on top. We lost a degree on the bottom. So what should you do? All right, if you plug in 0, what do we get on top? And on the bottom? Wait a second. What does that mean?
Run that shit again.
Again? How many L'Hopital does this problem have? No, if you do it again, am I going to make progress? Is it going to simplify?
Yeah.
Yes, it will. Which means go ahead and do L'Hopital if it's simplifying. What's the derivative of sine?
Cosine.
And on the bottom? What will I not get in the bottom? So I'm going to do L'Hopital yet again? No. All right, plug it in. What do we get? Cosine of 0 is 1 and 6. And there you go. If you do L'Hopital 3 times, and you think you still need to do it again, go. Kind of the max, unless you see a really good reason to do it again. Okay, you have to see progress in simplifying your function. Alright, so this next box here simply says, you can do L'Hopital as many times as you need to. As long as you have 0 over 0, you can do it again. Is it helping you? That's a judgment call. You have to look at it and see if you should do it again and again and again. All right, so here we have some limits that are one-sided limits. We did one-sided limits before. You still start off the same, don't you? How do you find a limit that's even one-sided? You still plug it in. What happens if I plug in 0 here?
0.
0 over 0. Uh-oh. What does that mean? Huh?
L'Hopital.
You're L'Hopital ready. Even one-sided limits you can apply L'Hopital to. However, the fact that it is one-sided is for a reason. It is not a good reason here, really. This function does not require the one-sided, but somewhere in your problem, the fact that it is approaching from one side will play a role in answering the question. All right, here we go. We're going to do L'Hopital. So the limit, as x goes to 0 from the right, what do we write?
Cosine of x over 2x.
Cosine of x over 2x is correct. What do you do now?
Plug it in.
If you plug in 0, top and bottom, what do you get? Remember what? Well, that's kind of funky. You guys remember test 1, right? We talked about 1 over or a number over 0. Anybody remember what that meant?
Isn't it asymptote?
Even yesterday we talked about this. If the denominator is 0, you have a whole vertical asymptote. Which one?
Asymptote?
To be a whole, it has to be 0 over 0. Because if you have to cancel out all of it, has 0 on top and bottom. This means you're a vertical asymptote. You are approaching a vertical asymptote here. What do you remember? Even yesterday we talked about this. When you approach a vertical asymptote, where are you headed? Positive infinity or negative infinity, or if the two sides don't match, does not exist. But we have only one side. Do you see why I had to do a one-sided limit here? It's because you're approaching a vertical asymptote. So how do we determine which side we're approaching, or which one of these infinities we're approaching?
Loving the number.
We test. Good. So here's my number line. We are approaching 0 from the right. Pick a close number. How close to 0 can you get?
0.001.
0.000. That's what I mean by close. Really, really close. Take that number, plug it into your function. So we have cosine of 0.0001 divided by 2 times 0.0001. I don't need the answer. I need to know if it's going to a positive or negative big number. So calculator, wonderful tool. Cosine of a very tiny positive number is what sign? That would be positive. The bottom is positive. A positive divided by a positive is a positive. This test here has now told you that yes, you're approaching a vertical asymptote, but because you're approaching from the right, you are going up that vertical asymptote to positive infinity. Questions? Can you ignore everything from test 1? No, this is an example of what you cannot ignore. Number divided by 0. This is something we did way back when. It can come into play. L'Hopital can simplify your problems, but it won't fix all of them. Let's try another one. It's a limit. What should you do? Actually, that's the same limit, isn't it?
Yes.
So the first step's still the same, right? We're going to get 0 over 0, which means we're L'Hopital ready. So we're going to do L'Hopital. Do I need to do L'Hopital again? No, this is the same. What's the only thing that's going to change?
Double.
Only the test changes. So for the test, here's my number line. This time I gotta pick something to the left of 0. Who is to the left of 0?
Negative.
That'll work. We plug that into our function. So we have cosine of negative 0.0001 divided by 2 times negative 0.0001. Any idea of what that is? Oops, I'm off my screen. Positive or negative? Bottom's negative. What's the top? It's positive. Do your calculator, it'll tell you. So we end up with a negative. Your limit, we know, is approaching a vertical asymptote. We just discovered when it approaches a vertical asymptote, it heads where? Negative infinity. Other questions about this? We good? All right, so just for review's sake, what if I had asked you as x approaches 0, no side? As x approaches 0, in general, what would the limit be?
Keep on being a bump down.
Infinite.
On one side you get positive infinity, the other side you get negative infinity. So what is the limit in general? Does not exist. Good review. Questions? It's
Yeah.
now. When can we have a test? I didn't know something is L'Hopital already.
It's okay on that one.
0 divided by 0. All of them. To that. Infinity over infinity is also L'Hopital already. Now I said infinity. How many infinities are there? A lot of them. 2. Positive infinity and negative infinity. Here's the reality. I don't care what sign you have in either place. It could be infinity over infinity, negative infinity over negative infinity and positive infinity, either way on top. I don't care. If you have an infinity over an infinity, that is considered to be L'Hopital already. You ready? It's a limit. What should we do first? Plug in, pi over 2. All right, this is great practice. Secant of pi over 2. You guys like these, right? Let's work that out on the side. What is secant of pi over 2? How did I find that? My calculator can't do it. Secant is 1 over cosine. So we need cosine of pi over 2. What's cosine of pi over 2? 0. So this is 1 over, wait. We just talked about this. 1 over 0. What does that mean? It means a vertical asymptote, which means that value has to be what? 1 of the infinities. So if I plug in here, I get either plus or minus infinity. I really don't care which one right now. I might need to figure that out later. Right now, I don't care. It's an infinity. On the bottom, we have 1 plus tangent. Well, let's analyze tangent. Anybody know what tangent of pi over 2 is? Well, it's sine over cosine. Does that help you? It's 1 over 0, which means the answer to that would be?
It's one of the infinities.
It's 1 of the infinities. Again, it's a vertical asymptote. Tangent at pi over 2 is plus or minus infinity. You have to add 1 to it. 1 plus or minus infinity will be what? Still plus or minus infinity. Wait a second. What does this mean? Infinity over infinity means what? L'Hopital already. Questions?
No.
So what do? Let's practice our trig. All right, derivative of secant.
Both. Oh, wait, secant is.
Secant x, tangent x, good.
Hey, sure.
On the bottom, the one does what?
Gets lost.
It's the derivative of 1 is 0, it's gone. Tangent, what's his derivative? Secant squared of x. All right, plug in pi over 2. We already know that secant is going to be plus or minus infinity, tangent is going to be plus or minus infinity, and all of these are plus or minus infinities. So you have infinity over infinity. Should you do L'Hopital again? You could, but can you imagine taking the derivative of the top? What would you require then? Quadrature. Does that sound like it's going to get nicer and better? This is where we have to start stopping ourselves before we jump to conclusions. Should I evaluate this now?
No.
No. Look at it. What should you have done first before you plug in? You should simplify. If you simplify, you have a chance of having something that is actually going to evaluate. L'Hopital would not have made this better, whereas algebra definitely helped. So this is algebra here. All right, now what should we do? Wait a second. We already know that secant is going to be what? Not the derivative, not the identity. We know that secant at pi over 2 is infinity. This is infinity. We already found tangent at pi over 2 is also infinity. What does that mean? L'Hopital or
Give up.
Isn't secant tangent something?
not give up. I wonder if trig could help me here. How could trig help me?
Break up.
You can use identities here. That might help you. Which one do you want to try? L'Hopital or identities? Let me give you a little hint. What's the derivative of tangent? What's the derivative of secant? You're going to get the same thing upside down, which was simplified to this upside down. Then you take the derivative of that, you get this like this again. You simplify, you're back to here. You take the derivative, it's this upside down. Simplify, it's that. You're in an infinite loop. If you continue to do L'Hopital here, you have to take advantage of the trig identities. You could not do that at the beginning because of the 1 in the bottom. It would not have simplified nicely. But here, you have just tangent and just secant, so you have to try identities. All right, so what is tangent? What is secant?
Both sides.
What do these cosines do?
That's wow.
They're gone. So your limit, as x goes to pi over 2, is the limit of who? Sine is all that's left there. Can you evaluate sine of x? I mean, sine at pi over 2? What is it? 1. You're done. L'Hopital is awesome, but don't go crazy with it. You have to know when to stop. Algebra before calculus. Trig identities before calculus. Questions? All right. Just gonna try a couple more of these. See how far we get. Oh my goodness, it's Ellen. You remember Ellen, right? Well, we don't even talk about Ellen. And we have to plug in infinity to Ellen. Do you know what infinity is? Here is Ln of x. Let's review. Here, x is 0. Not x is 0. Y is 0. What's the x value here? 1. So if you plug in 1, you get this point. That's y is 0. Ln of 1 is 0. If you're letting x go to 0 from the right, you're approaching what? As x approaches 0 from the right, we are approaching negative infinity. As x approaches infinity, what does Ln of x approach? Where is this going? As we go further and further right, what's the y value doing? It's increasing very slowly eventually, but it is increasing to infinity eventually. So there are a couple of things here that are going to be extremely important to you. The limit as x goes to 0 from the right for ln of x, negative infinity, which you're headed down here. The limit as x approaches 1, that's 0. That's the point. And then the limit as x approaches infinity, that's going out to the right, we go to infinity. These are three limits that are going to be important in L'Hopital. We do a lot in L'Hopital. Okay, we'll do most of it on Monday. We'll do a little bit right now. These are also very important for calculus 2. We do a lot of calculus 2. All right, let's try this problem then. We're going to plug in infinity. So on top, ln of infinity is infinity, headed to the right, infinity. On the bottom, this is square root of infinity. Infinity times 2. So what did we get? Exactly. What's infinity over infinity mean for us? L'Hopital ready, good. So let's apply L'Hopital. What does that mean? What should you do? All right, what's the derivative of? All right, the bottom is a little bit tricky. Is this really what you're going to take the derivative of? What are you really taking the derivative of? This guy. So what's his derivative? Good. The power came down and canceled out the 2. We have a new power. Now, if you plug in infinity right here, you're going to get 0 on top, 1 over infinity. You guys remember that? Number divided by infinity goes to 0. On the bottom, you also have a fraction, 1 over infinity again. This is 0 over 0. What does 0 over 0 mean? What we talking about? Does that sound like a good idea?
No.
These two are going to get messier and messier and messier if you try and use L'Hopital. Did the first step help us though?
Yeah.
What did we get rid of because we used L'Hopital? Getting rid of it is always a nice thing, okay? So it did simplify. But before I jump and start doing L'Hopital again, who should I consider? Algebra. Can you clean this up? How on earth do you do that? I know you guys love algebra. Don't overcomplicate it. Rewrite these in a form that makes more sense to you. You can leave them over x if you want, or how could you rewrite 1 over x? X to the negative 1. And then this guy down here, you can leave him underneath if you want. Or what else could you do with him?
Right.
Bring him upstairs. So we have x to the negative 1. If we bring the other x upstairs, his power becomes positive. Now, what operation is between these x's? Multiplication. Now, don't jump to polycule because you're still doing algebra here. X times x. What do you do with them? How do you combine them? Add the powers. Negative 1 plus 1/2 would be negative 1/2. That's pretty simple. I could plug infinity into that. However, it has a negative exponent. Let's get rid of the negative exponent. So take the x to the bottom. And then what does a 1/2 power mean? Square root. 1 over the square root of infinity is?
1 over infinity. 0.
So what is 1 over infinity? You did all of that for nothing.
Oh.
That's the answer.
Took you a second. 0, nothing. All right. I'll get just 1 or 2 Snickers out of my classes with that. That's okay. All right. Any questions? That was a lot. And it wasn't the calculus that was the hard part, right? It was the algebra. You're going to be practicing algebra here. Simplifying is very important. I got one more for you. E to the x. I'm going to draw e to the x over here real quick. You know what e to the x looks like? Whee! We good? All right, review. E to the 0 is
1.
1. E to the infinity. So as x goes to infinity, where's the function going? Infinity. And e to the negative infinity is, so as x goes to negative infinity, we're headed towards 0. Does it actually get there? No, but it's headed towards 0. So I'm going to put it, show it's headed there, but it's not actually. Okay, so what do we do first here? It's a limit. What do we do first? Plug it in. So e to the infinity is infinity. Infinity squared. Ooh, wait a second. What does infinity over infinity mean?
Look it up.
We got L'Hopital ready. So let's do it. What does L'Hopital say you should do?
Go into the top middle.
Derivative of the top and the bottom. So what's the derivative of e to the x? E to the x. What's the derivative of the bottom? What should we do?
Plug it in.
Plug it in. What happens if you plug in infinity?
Put it in. You put in one thing. Do it.
Which means you have L'Hopital ready, but do you have any other option? Could you simplify it instead?
Oh.
No. Is our function getting better? Simplifying.
Yes.
So let's keep going. Let's see what happens if we do it again. All right, limit as x goes to infinity. What's the derivative of the top? And the bottom? What happens if we evaluate this time? What do we get? What's infinity divided by 2? We got an answer. All right, there are 2 topics in L'Hopital that I attended. So I will do those on Monday. So have a wonderful weekend. Get your homework done. Paul, Alexander, Simon, I have stuff for y'all. Amaya, Andrea.